All right, so just to give you a brief history, TCP/IP is essentially a set of network protocols. It's a suite of protocols, and I showed you the three that we're going to be focused on. That's going to enable communications between computers or devices. Now, if two devices need to communicate together, they're going to use a set of common protocols or rules. And this is no different than what we talked about before with regards to the OSI model. Just as if people are talking in a particular language, there are rules. And I'm going to show you some of those specific rules so you understand what they mean. Because in a language, we have vocabulary, we have grammar, so those are some of the rules or some of the protocols that we have. And similarly, I'll show you what exists for some of these protocols. So there are many types of communication protocols and network protocols, but TCP/IP is the industry standard. Essentially, it's the language of the internet. So anytime you're talking about any networks that are connecting to the internet, you're going to be referring to this TCP/IP model. Now, having said that, there is some ambiguity and some cross-referencing of different models. So for example, you'll often hear people talk about layer 7 as the application layer, although there's no layer 7 in the TCP/IP model, but people still hold on to the OSI layer 7. And so sometimes there's this ambiguous use of terms, but it's just when you're clear in your head what somebody's referring to. So when they say layer 7, although it's still referencing the TCP/IP model because we're talking about the internet, they're actually talking about the application layer, and it's important to remember things like that. So the predecessor for TCP/IP was ARPANET, and ARPANET was, I guess, the predecessor to what is the internet, and that's where this came about. But the ARPANET protocol wasn't sufficient to be able to handle the growth and the scale of the internet. So in 1974, essentially, there's a paper published, and that became the beginning of the TCP/IP model. Okay, now, ARPANET ceased to exist in 1990, and then since then, TCP/IP has really taken over and become the main protocol that we leverage. All right, so here's the DoD model or implementation of the TCP/IP model on the left side here, and we compare it to the OSI model that we've been talking about up until now on the right-hand side. Now, just because it's a slightly different model doesn't mean what we've talked about up until now is not useful or changes in a significant way. There's a lot of overlap, and you can apply much of what we've talked about already. So you can see the differences here at the bottom two layers. The physical layer and the data link layer are combined in the TCP/IP model to be the network interface or the network access layer. And so it combines the data link layer and the physical layer, right? So this would include, for example, Ethernet, which we talked about last week. Then the second layer changes its name from the network to the internet. And for those of you who don't know this, or if it's not obvious, internet actually stands for inter-network. And it really goes to the essence of what that network layer is for, to be able to send traffic from one network to the other, right? Remember, from one IP address on one network to another IP address on a whole different network through routers and other such devices. Whereas this layer is responsible for keeping traffic or responsible for sending traffic on the same network. So, that's a good name for it, internet, because we're going from one network to the other, internetwork. But it's essentially the same as the network layer in the OSI model. The transport layer doesn't change. We're still talking about ports and protocols, and we'll go into more details there, but it's still called a transport layer. And then the application layer combines the application, presentation, and session layers of the OSI model. Okay. The main thing here is to understand, first of all, that there is this other model, the TCP/IP model. But ultimately, what we want to understand is what the protocols are at each of these layers, how these protocols work, what they do, what the advantages are, disadvantages, what the limitations are. Once you understand that, then if you're talking to somebody kind of in a different language, you can do a little bit of translation and get by, but be able to understand exactly what they're talking about. Okay, so let's talk about the network interface layer or the network access layer. So this is going to define how data gets physically put onto a network and sent to that network. Again, we're talking about sending data on the same network. So for example, the most simplistic version of this or view of this is if I have two servers or two hosts or two devices and they're just connected with a cable, right? That's one network. How does information get from one computer to the other, one host to the other? That's what the network access layer is going to define. It's going to define the cabling, the media through which those signals are carried, and it's going to define how those signals get onto the media. So you can see here, Ethernet is exactly one of those protocols. We talked about it in great detail last week, or yeah, in our last class. But you'll recall that we talked about cables and the CDMA, the protocol to put signals onto a wire so that there are no collisions. We talked about all of that. We recapped it today. But that's essentially what the network access layer is. How do I get data to another host on the same network using the physical media, okay, and the MAC address or physical address? Then we move up to the internet layer. So the internet layer is going to create these packets or these datagrams. And the responsibility, the purpose of the internet layer is what? Internetwork. How do I get data from one network to another network? And the definition that the TCP/IP model uses is IP addresses, and that's how it's going to get information from one host on one network to a different host on a different network. All right, and some of the protocols are IP, ICMP, ARP, reverse ARP, and we'll talk about all of these. I've just listed them here, but we'll talk about what these protocols are and what they're used for. IP is really the main protocol used to send information. Then these are more management protocols, and we'll talk about all of those and see what they're used for. All right, so third, we have the transport layer. The transport layer, as you remember, is defined by ports and protocols. All right, and the protocol is going to be either TCP and UDP, and then the port is going to be anything up until, if you have 65,000 ports that you can use, but each service or each application is going to have to define for themselves what port and what protocol to use. And the protocol actually will be quite important. These two protocols, and we're going to spend some time talking about what these two protocols are, the advantages and disadvantages, why you would choose one versus the other. But each application has to make a decision, and that decision would impact how your application performs, whether or not there's error correction, whether or not it's tracking packets that are going from one host to the other. But essentially, it is taking information based on a protocol and a port and routing it from the application or the service on this side to this application on the destination. All right, and then finally we have the application layer. Sometimes you might see it called as the process layer. As I said, sometimes this will actually be called layer 7, even in the TCP/IP model. But the application layer is just that. It is at the highest level, right? Almost at the user level. How do you get one application to talk to the other application? And so you're going to see, we're going to talk about ways in which applications are going to communicate with one another. And each of these applications or each of these services or processes is going to have a different type of protocol. So some of the protocols are going to apply to, let's say, email. How is email sent from one application to the other? Or how is it received from one application to another? How do we transfer files? That's a common thing that we want to get done. And so how do you transfer files? And so you have a specific protocol for that. I want to remotely log in to a server somewhere. How do I do that? Well, there are protocols for that to happen as well. Because in order for these things to happen, both systems on either side of the wire, if you will, have to agree on the protocol, on the language. So everything up until now, getting the network or getting the information onto the network, onto the wire, finding the location of the machine by IP, deciding how to send it at the transport layer. That's all defining how do I take all this information and just send it back and forth, right? You can think about it this way. Let's say we're having this conversation, right? We have to decide how we're going to communicate. Well, we're going to communicate via video conferencing. In particular, we're going to use Zoom. I'm going to use my computer audio, and I'm going to use these headphones. You might be using a speaker to listen to it. So all of that are the details of the connection. So that's everything, from the network interface up until the transport layer. But what's the purpose of doing all of that? The purpose of doing all of that is the so-called application, right? Or in this case, the educational component, me being able to communicate with you certain topics and convey certain information. So all of those other details are here, but now how do I communicate to you? Well, we have to have certain rules. We're going to speak in a certain language. I'm going to have slides available. I'm going to talk. If I ask a question, somebody will respond. If somebody wants to say something, they put something in Slack. Those are the rules of the high-level purpose or the application, if you will. So everything up until the application layer is, how are the bits and bytes and data sent back and forth? But really, why are we doing all that? We're doing all that because we have an application. We have an email application, or we have a file transfer application or what have you. And that's really the purpose of this application layer, to define those protocols for those different purposes for applications to communicate with one another.